Hello everyone, welcome back to the DSA series. In this video, we are going to solve LeetCode 128, longest consecutive sequence. This is a very interesting hash set problem because the obvious solution is actually quite simple, but it does not satisfy the required time complexity. So first, let's understand the problem. We are given an unsorted array of integers. We need to find the length of the longest sequence of consecutive numbers. For example, suppose we have 100, 4, 200, 1, 3, 2. The longest consecutive sequence here is 1, 2, 3, and 4. These numbers are consecutive because every next number is exactly 1 greater than the previous number, and therefore the answer is 4. Notice that the number do not need to be consecutive inside the original array. The array is unsorted. We just need to check which value are present. The first solution that probably comes to mind is sorting. If we sort this array, we will get 1, 2, 3, 4, 100 and 200. Now it will become very easy. We can simply iterate through the array and keep checking whether current number is previous number plus 1 or not. We would find 1, 2, 3, 4. So the longest length is 4. This solution is logically correct, but there is a problem that sorting will require n log n time, and the question specifically tells us you must write an algorithm that runs in big O of n time. So we need something better. Whenever we want very fast lookup of whether a value exists, a hash set is usually a good option. We can put all the numbers into a set. For example, 100, 4, 200, 132 will become conceptually this in a set. Now, checking whether a number exists inside this set will take big O of 1 average time. For example, we can ask, is 2 present? Is 3 present? Or is 4 present? And these lookups are very fast. But there is still one important question. If we start checking a sequence from every number, we could end up doing unnecessary repeated work. Suppose we have 1, 2, 3, 4. If we start from 1, we will check that 1, 2, 3, 4. Then if we start from 2, we will check for 2, 3, 4, right? And then from 3, we will check 3 to 4. This repeated work could make our algorithm inefficient, so we need one more observation. We should only start checking a sequence from the first number of that sequence. But how do we know whether a number is the first number? Very simple. For any number, check whether the number minus 1 exists in the set. Check that num minus 1 exists in the set or not. If num minus 1 exists, then num cannot be the beginning of the sequence. For example, consider 4. We will ask, is 3 present? Yes. So 4 is not the start, right? So what about 3? Is 2 present? Yes. So 3 is also not the start. So what about 2? Is 1 present? Yes. So 2 is not the start. Finally, consider 1. So is 0 present? No. Therefore, 1 must be the beginning of the sequence. And only now do we start moving forward. 1, 2, 3, 4. Then 5 does not exist, so the sequence ends and its length is 4. This single check, if num minus 1 not in num set, is basically the heart of the entire problem. So our complete algorithm is: first convert the array into a set, then create a variable longest equal to 0. Now iterate over every number in the set. For every number, we will check, does num minus 1 exist? If it exists, do nothing because this number is something in the middle of a sequence. But if num minus 1 does not exist, then we have found the beginning of a sequence. Now we keep checking num plus 1, num plus 2, num plus 3, and so on until the next consecutive number is not present. We calculate the length of the sequence and update our maximum answer. Finally, return the longest length. The pseudocode looks like this. Now let's implement this in Python. First, convert the array to a set. This does two useful things. First, it allows us to check whether a number exists in approximately big O of 1 time. Second, it automatically removes duplicates. Now initialize longest from 0. This will store the longest sequence length we have found so far. Next, we will iterate over every unique number. We Now comes the most important condition. This means we only continue if num is the first number of a sequence. If previous number exists, we skip the number. Now we initialize. Our sequence currently contains at least this one number. Then while current plus 1 in num set, as long as the next consecutive number exists, we continue. Inside the loop, we will increment current by 1 and current length by 1. After the sequence ends, update the answer. Finally, return our longest variable. Let's try run with example 1. Our input is this array. After creating the set, conceptually we have this set. Remember that the actual order inside a Python set is not important. Let's examine the values. Suppose we consider 100. We check 99 in the set. No. So 100 starts a sequence. Okay. We initialize current equal to 100 and length equal to 1. Now we will check that 101 in the set. No. So this sequence has length 1. Our longest become 1. Now consider 4. We will check that 4 minus 1, that is 3, is in the set or not. Yes, 3 is in the set. That means 4 is not the beginning of its sequence, so we will skip it. Now consider 200. We will check 199 in the set or not. So 199 is not in the set, so 200 starts another sequence, but 201 does not exist. Length is again 1. Now consider 1. Now we will check that 0 in the set. No. So 1 is the beginning of a sequence. Initialize current equal to 1 and length is 1. Now check 2, last element. So 2 exists. So current is 2 and length is 2. Check 3. 3 exists. Now current is 3, length is 3. Check 4. 4 exists. So current is will be 4 and length will be 4. Check 5. 5 does not exist. So our sequence is 1, 2, 3, 4. Therefore, longest is 4. The final answer is 4. Now dry run the example 2. Notice that 0 occurs twice, this element and this element. After converting to a set, duplicates disappear. So conceptually we will have, now take 0. Minus 1 exists? No. Therefore 0 starts the sequence. Now we continue 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9 does not exist. So the sequence length is 9. After, what happens when we later reach 1? We check 0 exists. Yes. So we skip 1. Similarly for 2, 1 exists, skip. For 3, 2 exists, skip, and so on. Therefore, we don't repeatedly traverse the same sequence. The final answer is 9. Now consider this array. If duplicates were not handled properly, we might face problems. But because we convert the array into a set, the duplicate 1 disappears. 0 has no predecessor because minus 1 is not present. So we start from 0. 0, 1, 2. Length is 3. That is our answer. We should also think about an empty array. The set will also be empty. Our loop will never execute and longest remains 0. So we currently return 0. We don't even need a special condition for the empty array. Why is this big O of n? Now there is the most important complexity discussion. We have a for we have a for loop. Inside the for loop, we also have a while loop. So someone might look at the code and say, isn't this big O of n square? No. The reason is that we only enter the while loop when we are at the beginning of a sequence. Suppose our sequence is 1, 2, 3, 4, 5. We traverse the complete sequence only when we reach 1. For 2, we see that 1 exists, so we don't traverse. For 3, we see that 2 exists. For 4, 3 exists. For 5, 4 exists. Therefore, every number participates in sequence traversal only a constant number of times overall. Across the entire algorithm, these while loops together process at most big O of n elements. Creating the hash set also takes big O of n average time. Therefore, total time complexity is big O of n on average. We are storing all the numbers inside a hash set. If there are n unique numbers, the set can contain up to n elements. Therefore, space complexity is big O of n. Now let's submit the solution once. Before finishing, let's discuss some common mistakes. First mistake, you might write nums dot sort and then solve the problem. Then that solution can be correct logically, but sorting takes n log n time. The problem specifically asks for big O of n, so hash set is the preferred approach. The second mistake, that confusing consecutive with adjacent. The numbers do not need to appear next to each other in the input. For example, the array 104, 200, 132 contains 1, 2, 3, 4. Even though they appear in different places in the original array, we care about consecutive values, not consecutive indices. The third mistake, ignoring duplicates. The input may contain repeated numbers, for example 1, 0, 1, 2. The longest consecutive sequence is 0, 1, 2. Its length is 3. The repeated one does should not increase the sequence length. Using a set naturally solves the problem. Now let's quickly recap. We need the longest consecutive sequence in an unsorted array. Sorting would give us n log n, but the problem asks for n big of n time. So we store all values inside a hash set. Then for every number we ask, does num minus 1 exist? If yes, the number is not beginning of a sequence, so we skip it. If no, we start a new sequence from this number and repeatedly check num plus 1, num plus 2, num plus 3 and so on. We calculate the sequence length and keep track of the maximum. The key line to remember from this entire problem is if num minus 1 not in num set. That one condition ensures that we only explore each consecutive sequence from its beginning. Our final complexity is big of n average and space big of n. And that solves LeetCode 128 longest consecutive sequence. If you understand this idea, try implementing it once without looking at the code. That is the best way to make the hash set pattern stick. I'll see you in the next problem.